Okay, friends, I am back with the rest of lesson 30. Same area, different perimeter. So we're taking what we know about perimeter. It's going to have the same areas, but different perimeters. So areas, how much space something takes up, but it could have a different distance around, which is interesting. Read the problem below, then explore different ways to find rectangles with the same area and different perimeter. And I'll try to zoom a little bit again. You won't be able to see very well, but you have your own book. Please use it. Emma. Xavier. Hi, Xavier. Miss ya. Xavier drew the rectangle at the right. What other rectangles have the same area but different perimeters? Picture it. So again, we want to find the same area, that's blocks, units in between, inside, but different outsides. You can use the drawings to help you find rectangles with the same area and different perimeters. The area of Xavier's rectangle is 16 square units. Don't believe me? Let's count. 1, 2, 3, 4 times 1, 2, 3, 4. 4 times 4 is 16. Okay. Below are two other rectangles that also have an area of 16 square units. These are not the same rectangles as Xavier's first rectangle, yet they have the same area, which you might remember from when we worked on area, but they will have different perimeters. That's the distance around. You can also turn these rectangles on their sides. You would have one rectangle unit wide and 16 tall, and another rectangle 2 units wide and 8 units tall. Model it. And I know it'll probably ask you, yes it will, so I won't go over this quite yet because it asks you on the next page. You can use a table to help you find rectangles with the same area and different perimeters. You can make a table showing the measurements of rectangles that have an area of 16 square units. The rectangle Xavier drew is circled. So these are all areas of 16 square units, and you can see this length, width, area, perimeter. So area, 16 square units. That's the one he drew. 4 units the length, 4 units the width. And then if you count all the way around, it would be 16. Because if one side is 4, the other side is 4. So it's 4 units and 4 units and 4 units and 4 units. And that would be 16. Connect it. Let's see if you can see that. It's a little harder. Okay.
Are you on to the other page?
Yes, on 311. Look at, picture it. How can you tell the two rectangles shown have the same area as Xavier's rectangle? Well, how can you tell is you can multiply length times width. Okay, so if you did this on your own, if you said I could count all of the squares, you would be correct. However, I know that you can take this a little further, and you know how to find area, which is length times width. I can multiply L times W equals A. And let's try it. You don't believe me? Who doesn't believe me? You don't believe me, Sophia? Let's do it then. So length, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 times 1 equals, because it was a 1 up, 16, you got it. So we're jumping back to finding area and how area and perimeter are related. So don't get confused. Okay, here we go. Length. 1, 2, 3, 4, 5, 6, 7, 8. 8 times 1, 2 equals 16. Ooh. Square units. One of you would have reminded me that, because I am talking about area. Okay. So again, I can multiply length times width equals area. To find other rectangles with an area of 16 square units, think of multiplication facts with a product. That's the answer using our math words. The product of 16. What are the multiplication facts that have a product of 16? And now I want you to pause this video and figure out as many multiplication facts as you can that would equal 16. Many of them are, well, I don't want to give it away. Okay, let's give it a try. Pause. Hopefully you paused the video. There was a place to find all the answers, and that was in the chart over here. But I'm hoping you found these on your own. So we could have 1 times 16. That equals 16, right? How about, and I know some of my friends love this one. They always remember it. We can switch the factors. 16 times 1. Yep, that also equals 16. Okay, let's try another one. How about, and again, if you're not sure, you just start somewhere, just like on Prodigy. So start with 1s, then go to 2s. What, is there anything times 2 that could equal 16? You betcha. 2 times 8 equals 16. Likewise, you can switch the factors. 8 times 2. Okay, got one more. 4 times 4 equals 16. Look at the table and model it. Where do you see the factors and products of the multiplication facts you wrote? So, look at this table, friends. Where do you, they're asking you what category you found those in. Where did you find those numbers? Well, we found them in the length and the width. See? 16 and 1, 8 and 2, 4 and 4, 2 and 8, 1 and 16. So, where do you see the factors? I see them in the, and I'll just like, you put L and W categories. Okay, so, and those are the sides, friends. Just the sides. Okay. Can two rectangles have the same area, but have different perimeters? How do you know? So, we already know this, friends. Look at this page. We have 3 rectangles with exactly the same area and different perimeters. Yes. I know. Because Well, how do you know? We know because we saw on the chart and saw the drawings. I looked at the drawings. I'll say that's for the chart. Different factors can be used to find a product. That's kind of the big thing there, is that once you have the product or the answer or the area, then you find all of the different factors. Those are these numbers that you could use. And those will be all of your options for perimeter, as long as it is a rectangle. So try it. Use what you just learned about area and perimeter to solve these problems. Show your work on a separate piece of paper. I do want you to show your work, but we can cram that in there, I think. Look at this rectangle, below. Draw a rectangle that has the same area, but different side lengths. So it's going to have a different perimeter. Let's find out the area. So let's count how many over the length. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 times 2 equals 18. So take a moment and find different factors that could make 18. I always say start with 1. We already are at 2. Maybe there's something times 3. 4, 5, 6, 7, 8, 9. I wonder what you're going to choose. I know what one I am choosing. So I'll give you a couple options. I would prefer it if you... Oh, it's got to have a different side lengths. So please don't switch the factors here. While that is technically switching the side lengths to length and width, I'm going to say not that.
I finished the page.
Okay. Let's go to, maybe you did 9 times 1. Excuse me. Or distracted me. 18 times 1, or maybe you did 1 times 18. And then you can draw that out.
The next page has one of these too.
Oh, cool. So if you drew that out, if you remember fractions, you would do one less line to get the boxes. So you would need to draw 17 lines. Let's see if I can do that evenly. If yours isn't even, we'll pretend that it is. We have great math imagination sometimes, don't we? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay? Pretend those are all beautiful square units like that one. 18, or you could do that sideways. The one that I was thinking of, wonder who thought of this one. 6 times 3, or 3 times 6. And then how I would do that one is I would draw one box with 6 in it. So one less line. 1, 2, 3, 4, 5. And then I'd go down to make my 3 boxes like that. And I could simply use those lines. Or just draw a big rectangle and split it like that as well. So all of those, same area, different perimeter. Look, so now I'm on 13. Look at the rectangle you drew for problem 12. All right, so, well, I drew lots of them. I'm going to look at mine that I chose. Is the perimeter the same, greater than, or less than the perimeter of the rectangle shown? Oh, guess we need to find some perimeter, friends. Let's do some adding. So I knew that this was 9. over. I know that's 2. I know that's 9. And I know that's 2. So you can do this a couple different ways, add as you go. Maybe you want to take 9 plus 9, which you might have to figure out for a moment. Maybe pause the video if you need to. 9 plus 9 is 18. And then 2 plus 2 is 4. 8, 9, 10. Carry my 1. 20. Okay, this one has 20. Sorry, I maybe should have done it on a different piece of paper today. It's easier when you're in class with me because I can write it. Okay, let's find the perimeter of this lovely shape. 1, 2, 3, 4, 5, 6, which means this one is also 6, which this is 3, and this is 3. So maybe you saw, oh look, 3 and 3 I know make 6. What's 3 6s? 6, 12, 18. If you didn't know that, you could do 6 and 6, 12, 3 and 3, 6. If you didn't know any of those, you could just simply count as you go. 12 plus 6 is 18. So, oh, and if anyone did do this one, so this would have been 18, this would have been 18, this is 1, and this is 1. Some of you, probably most of you, will need to set 18 plus 18 up. 8 plus 8 is 16. Carry my 1. 1, 2, 3, 36, the perimeter. So the question is the perimeter the same, greater than, or less than the perimeter of the rectangle shown? I'm going to use mine, like I said. So in my case, it would be less. If you drew this one, then you would put greater. So it really depends. And it's just kind of neat that the perimeter changes. So if you had to build a fence with the same area, you know, your dog would have the same, let's go back to James again, Zophia's dog. James would have the same area to run around in, but if Zophia had to purchase the fence for it, then she would really want to consider building James's play area out of this, because she would have to buy less fencing because it's only 18, we'll say, feet. I know we're doing square units here, but so this is where area and perimeter can be very important to understand. How are we on time? Another 18 minutes. Okay, I'm gonna do another video, friendly friends. Hope you're doing well. Moving on in the next video.